start the record. Yes, Shreya, tell me. Yeah, you can ask. You can ask. So when you write A minus B, what we say is A and minus B vector. So we are trying to find the resultant of which two vector? A and minus B vector. Now, if I want to put it in a graphical manner, there is a very fine way of doing it. Let me show you. In the same triangle, can we draw minus B? A from the tip of the A, draw minus B. And you can see minus B will look like exactly opposite of B vector. You just need to flip the B vector. So once you flip it, the name will be called minus B. So minus B itself is the name of the vector. So is negative doing anything? The answer is no. The negative is only reversing the direction. What about the length?
It stays the same.
Which means, can we say that mod of B vector is same as mod of minus B vector? Of course, we can say this because lengthwise they are equal. So whether you write modulus for B or you write modulus for minus B, it turns out to be same length. Let's call it B. So now if I apply the triangle law for A and B vector, A and minus B vector, how it will look like? A and minus B will give you this resultant, the beginning of the first vector and the tip of the second. So graphically, this blue line is your R dash, isn't it? And clearly you can see something. Which length is bigger, which length is smaller? Lengthwise, R is bigger and R dash is smaller. Can you see that? Now the big question is it always true? So first question, what is the angle between vector A and B? What is the angle between vector A and B? Tell me, guys.
So theta.
What is the angle between A vector and minus B vector?
So
Sir,
theta.
what? 180 minus
Angle
theta.
between A and minus B vector. You have to look carefully in the diagram, then we can tell.
Sir, 180 minus theta.
That's correct. Very good. See, if you extend the A vector, hypothetically here, this is your A, and the below is the B vector, isn't it? This is the B vector with arrow. Now this is the tail to tail. And if you join A and minus B tail to tail, the angle is how much? And this angle is how much? Phi minus theta. Understood? So what is the takeaway from this discussion? The takeaway is, if now this is something very, very important, we need to write it down. If oh, So if the angle between vector A and B is known as theta, then the angle between vectors A and minus B will be pi minus theta. This is always true. Understood? So if you know the
So,
angle between this,
so wouldn't angle between A and minus B be theta if we take it as vertically opposite angle?
A vector and which vector? Minus B.
Minus B, yeah.
So the angle between vector B, how we take? By joining either tail to tail or head to head. Now you can see here, this is not tail to tail. So to get the answer first, you need to make them either a tail to tail or head to head. How to do? We can slide it forward, backward. We can slide. So we can slide here. Now this has slid to this position. Once you slide this vector to this new position, you can see these two are tail to tail. And now we can talk about the angle. Okay. So that was something we discussed in the last lecture. Okay. So I have shared the video. You can watch it again. Okay. So to find the angle between the vector, the rule is clear, guys. Either you join tail to tail or head to head, and that's why we studied something called the co-initial vector or co-terminus vector. So the simple rule is you must make them co-initial or co-terminus before you think about the angle between the vectors. All right. I hope this part is clear, guys. So if this part is clear, then you can clearly see this angle is obtuse angle or acute angle. In this case, in our case that we are discussing right now, this is obtuse angle or acute angle.
Acute.
Yeah, this is acute angle. So if angle is acute, sorry. So if angle is acute, now tell me which one will give bigger answer, the summation or the difference? So R dash is A and minus B resultant. Which we can also write as A minus B. And R is the resultant of A and B, right? So which magnitude is bigger, R or R dash? R is bigger lengthwise, you can see clearly. So we all can see that this length is bigger than this length, right? But when this is true, when theta is acute angle. So when theta is acute angle, then we can say that mod of A plus B will be bigger than mod of A and minus B. So mod of A and B vector, see, it's pure literature. We are not adding anything. We are saying that A and minus B modulus. And this you can write as A and minus B, which you can write as A minus B. Always remember, in vector we say addition. We don't say subtraction. So every subtraction should be interpreted in terms of addition. Okay. How? By putting the minus with vector, and that will reverse the direction. So A and minus B together produces some effect. What is that effect? We call it resultant of A and minus B, or simply A minus B. Now, while finding the magnitude, we can see clearly if theta is acute, the summation will be bigger than the subtraction, correct? That's very much, you can say, visually clear also why it is so. Now, let's change the angle. Let's change the angle. So, we have a vector A, and my B vector is something like this. You can clearly see that the angle between these two vectors is this one. Why? We must join tail to tail to check the angle. So now, because theta is the angle, is theta is acute or obtuse, guys?
Obtuse.
Obtuse, for sure. So the resultant, how we find the resultant in triangle law? We join the tail of the first with the tip of the last vector in the reverse direction. So this is called the resultant R vector. This is the resultant of A and B vector. Now I would like to know what is A minus B. For that I need to first reverse the B vector, isn't it? So if I reverse the B vector, it will look like this. So what will be the name of this new arrow? The name will be changed to minus B. It's just a conventional name. Now, as per triangle law, what we do? Tell me, guys. We join the tail of the first, which is A, and tip of the last. Once you join in this direction, this is called resultant of A and minus B. Let's call it R dash vector. Now, which one is bigger? The difference is more than summation, right? So, of course, vector summations are very unique. I mean, you will never realize that the difference can be bigger, right? And the sum can be smaller. That's quite possible. It's all the magic lies in the angle. So once you realize the angle part, you can actually understand, okay, as we will play with the angle, as angle will change, the resultant will dramatically change, and we'll see through it. So if theta is more than 90, what we can see clearly, the mod of A plus B, the magnitude of the resultant of vector A and B turns out to be less than magnitude of resultant of vector A and minus B vector. That's how we read it. It's literature. And you can further rewrite as simply A minus B. Okay. So now the reason behind the change is that the angle between these two vectors and the angle between these two vectors are not same. They are complementary. They are supplementary. They are supplementary, right? What is supplementary?
So sum is 180.
Sum is 180. So if this angle is theta, if the angle between A and B is theta, the angle between A and minus B will be
180 minus theta.
180 minus. Okay. And 180 minus theta can be less than, can be acute also. If theta is obtuse, the difference will be acute now. So acute angle gives bigger value. So if the angle between two vectors is acute, it means it will give you bigger value than the obtuse angle scenario, always. Okay. So earlier theta was acute, so pi minus theta become obtuse. Now theta is acute, obtuse, so pi minus theta becomes acute. So the moment you take a bigger angle than 90, this is obtuse and this is acute. It has changed now. So what is the takeaway from this discussion? That the change of answer is due to the change of angle. The length of the vector is still same, isn't it? Do you realize this? So we have one unique scenario when both will be same, and you can guess it. When the sum and difference will be same, when the angles are equal, when this angle and this angle both turns out to be same, your answer will be same. Look at this. It's very easy to understand. This is A vector, this is B vector, and these two vectors are exactly at right angles. So what will be the resultant of these two vectors? The tail of the first. So A vector, B vector, this is the resultant, and we can call it A. Now, if I reverse the direction of B, if I call minus B vector, this will look like this. And even by reversing the direction, the angle between A and minus B is still 90. And therefore, you can see the resultant has no effect in length. So lengthwise, both are same. So you can see clearly the Pythagoras can tell you the answer. Both are same length. Do you realize this? So this is the case when theta is 90. So we saw the acute scenario, obtuse scenario. What if we have exactly 90? So theta is 90, so pi minus theta will be also 90. There is no change in angle, right? So length is anyway same and angle is also same. So answer of the resultant must be same. So we can say that if theta is 90, then mod of A plus B or mod of A minus B will look the same, isn't it? Will look the same. Do you realize this? And this is better. Okay, you can visualize this by simple triangle. So once you draw the triangle using the triangle law, the vector part is gone. If you want to understand the magnitude part, just think as a triangle and do whatever you can with triangle. Okay, I'll show you some examples to understand better.
So your pi is 180, right?
Right, right. Pi radian is 180 degree. So pi is called the angle in radian. Okay. And the value pi is how much? So it is an irrational number.
Excuse me, sir. Excuse me, sir.
Hmm?
सर एक्चुअली मैं लैपटॉप की बैटरी डिस्चार्ज हो रहा है लैपटॉप का चार्ज हो रहा है
अच्छा, चार्ज करो, चार्ज करो. So pi is 3.1415. All right. So you just need to remember the first three digits, 3.14. That's sufficient. And pi radian is equivalent of 180 degrees. So you can express like this. So pi by 2 radian is how much?
90.
90.
90. So pi by 4 radian is how much?
45.
And pi by 3 radian
60.
60.
and pi by 6 radian
30
30.
So these are the values which one should remember. Rest we don't need. In normal physics, we come across this. One more value which is very common: 2 pi by 3. It's a double of pi by 3, twice of pi by 3, which is 120. Okay. And there's one more famous, which is 3 pi by 4. It's 3 times the pi of 4. What is pi of 4? And 3 times will be 135. So these are some typical values which you will encounter in solving numerical, and that is why I just simply mentioned for your reference, just in case if it is new to you, you will find a bit difficult. Okay, so not very difficult. Just you need to write in this simple fashion. I hope this is clear. Okay.
Yes, sir.
So now knowing all this relation, we can do some numerical. So first of all, you have to write the triangle law. So the first question we are going to solve is called identify triangle law. Okay, so I'm going to draw some triangle. You will tell me what is the law. Okay. Tell me what is the law.
So we have to say the equation.
Yeah, the equation that is equals to sum of. So which two vector will add up to give the third vector?
Sorry, and C.
Very good. So B vector is the resultant of A and C. And how to identify? We check the arrows in order. This arrow is in order, and this is in the reverse order. So those arrows which are in order, we add them, and then the third we write as the resultant, because this you can see is joining the tail of the first to the tip of the second. So B vector is joining the tail of the first to tip of the second. So this is the law. So the law is B vector is resultant of A and C vector. What we can say here, B vector is the resultant of A and C vector. Is this clear? For some reason, if I call this angle as 60 degree, what is the angle between A and C? What is the angle?
120.
120. Very good.
120.
So angle between A vector and C vector is 120 degree. Is this part clear? Because the tail to tail assumption will let you say that you have to extend C this way. So only when you extend the C towards left, they will join tail to tail, and so the angle becomes 120. Is this part clear? Share. Is this clear?
Yes.
So the angle between A and C is 120 degree. And why it is important? Why it is important? Because the resultant of the magnitude of B, how we write? By the relation. We have A and C, two vectors, we can write under root of mod of A square mod of C square plus twice of mod of A mod of C into cos of angle between A and C. What is the angle between A and C? 120. To write in a better way, I mean, if you do not want to use the modular sign, you can just write the alphabet A square C square 2AC. And now cos 180 I will tell you is minus half. Okay. So I will tell you later on how to get the cos 180 value. And you can see this will cancel out. So the length of B vector turns out to be how much? A square C square minus A. Simple. Fair enough. Okay. So
Yes.
if given A and C, I can find B vector directly by the formula. Given A and C, I can find the B vector directly by the formula. Okay. And formula we have derived in the last lecture. So what is the formula? The resultant of two vector formula. I hope you know. So resultant of A and B vector. How we write? Under root of first vector modulus square, the length of second vector square, length, only length square plus twice into length of first, length of second, into cos of angle between vector. And now if you choose the angle symbol theta, this will look nice. What you can write now? Simple, fair enough. So mod of A plus B is how much? This much. So given angle theta, if given angle theta represents angle between A and B, then find the modulus of A minus B. So what is given to you? The angle between A and B. So how to find the modulus of A minus B? So we will use the same formula, the topmost formula, under root of A square, the length of first vector. And the better way of writing is, now reading literature will be easy now. A and minus B. So length of A is A. Length of minus B is also A, B only. Length never changes, right? 2AB cos. Now we need which angle? We need angle between A and minus B. But fortunately or unfortunately, what is given to you? Angle between A and B. So angle between actual vectors is given. And now what we need? Angle between vectors A and minus B. But we know the relation. They are supplementary. Okay, they are supplementary. So what we can write here? Phi minus theta. And we're done. But if you know from trigonometry, cos of 180 minus theta is minus cos theta. Now this is the relation from trigo. Okay, I'll explain in trigo part, don't worry. So cos of 180 minus theta is minus cos theta. And because of this reason, this formula eventually looks like in fact, most of the students they mug up the answer. They remember like this: minus minus plus plus. But they don't realize why this formula came into picture first. Okay. So we are not changing the sign here. We are writing the angle differently. And that has resulted into this particular formula, which looks like the minus has brought minus here in the formula. A plus B whole square, A minus B whole square. A square plus 2AB plus B square, A square minus 2B plus B square. So that is how they think. And that is why this formula is mostly misunderstood. So they know the formula, but they don't understand. But what I want you guys to understand the formula. If I would have given the theta as angle between A and minus B directly, I would have used this only, no? Plus, correct? So if the angle between vector is known, we write the plus form. If the angle between the vector is given and they want the difference by reversing the direction of one of them, then it becomes minus pi minus theta, the new angle. And then we substitute to get the new answer. Sorry, guys. So now I will just put it as a summary. If angle between vector A and vector B is theta, then mod of A and B will be how much? A square plus, tell me guys, B square.
2AB cos theta.
Very good. And at the same time, what will be A minus B?
A square plus B square minus 2AB.
And why we are writing like this? Because the theta belongs to A and B. And what we need is A and minus B angle, and which turns out to be pi minus theta. And so the formula changes. Okay. So if I tell you that angle between A and minus B is alpha, then what you would have written? If I tell you that the angle between A, so if I would have tell you that the angle between A and minus B is alpha, what will be your answer of A minus B modulus?
A square plus B square plus 2AB cos alpha.
Excellent. So you got it. This is the idea behind A plus B and A minus B. Now, why the difference can be bigger than the summation is obvious. Cos theta is a function which can be positive also, which can be negative. And because of that reason, if it is a negative or if it is positive, it will change the length. So when the length will not affected by the plus minus, when cos theta is 0. If cos theta is 0, then nothing will happen. Whether you take the first formula or second formula, you will get the same answer, isn't it? So whether I take this one or this one, the answer will be same. If cos theta is 0, and when cos theta is 0, by the way,
When angle is 90.
exactly. So when angle is 90, the cos is 0, which means it will give you the same relation. So at theta equals to 90 degree, the mod of A plus B will be A square plus B square, just like Pythagoras. You can just use the Pythagoras, don't use the formula at all. And mod of A minus B is also same, Pythagoras. Okay. And both values are same, which simply says that in case of right angle, the A plus B modulus is same as A minus B modulus. So this I proved graphically, now we are proving mathematically. Okay. Because when theta is 90, cos theta is 0. and this automatically changes into this answer. Okay. Now tell me, so mathematically, if I write mod of a plus b is twice of mod of a minus b, can you guess the angle without solving? Can you guess the angle? What angle should be? When the summation is bigger than the difference, it's 2 times. So which one is bigger? The sum or the difference? The sum is bigger, no? So when the sum will be bigger in length? When the angle is obtuse or acute?
Acute.
Exactly. Only the acute angle gives the bigger value. So if a plus b is bigger than a minus b, because of the relation given, it's obvious. We can clearly say that the angle between them is acute without solving. No need to solve. We can guess it. And if I change the relation like this, now which one is bigger? Now the difference is bigger than the summation, which means the difference must be having the acute angle. The summation must be having obtuse angle, right? So we can say the angle between a and b vector will be obtuse or acute. Angle between
Obtuse.
a and b vector will be obtuse. Now you are able to say these things without solving, isn't it? So somewhere the graphical representation or the idea, this should lie within your mind. You should be able to draw these graphs in your brain. Until you're not able to draw these graphs in your brain, you will find solving question a bit difficult. So try to understand like these things should be in, we should be able to create this relation somewhere in our brain, and then you can play with it. Okay. So let's take some question. Okay, because we have understood the meaning of this. So
Sir, I have a doubt.
yes, please.
Sir, in that statement where you have written minus 2ab cos theta.
Mhm,
So, sir, if they have given angle between vector A and minus b vector
mhm, mhm.
then it won't work, no? Then we have to find supplementary of it.
No, if the angle is given between a and minus b, I have to use this one. No? The theta represents the angle between the vectors given, whom you add, right? So what you add here, here we are adding a and minus b. So if you give me angle between a and minus b, which Prashansa has already said this answer. If alpha is the angle between a and minus b, the answer will be how much? Let me
Pi
know.
minus alpha.
No. Alpha is the angle given. If alpha represents angle between a and minus b, if the alpha is directly given, the resultant will be how much? A square plus b square plus 2ab cos alpha. We cannot use minus, no? Because the angle itself is given for these two vectors, a and minus b. Now this formula is kind of confusing. This theta is angle between a and b given, and you are trying to find the resultant of a and minus b. So in derivation, I have clearly written, if the angle between, this formula says that a square plus b square plus 2ab cos of angle between vectors a and b. So we have this relation. So when you write something as plus, then we need angle between these two values, these two vectors, A and the other one, which can be plus B or minus B. Clear?
Fine, sir.
So here, while deriving, the theta was representing the angle between A and B, and what we really wanted is the angle between A and minus B, which is not given. But luckily, from the supplementary relation of the angle, we were aware that if the angle between A and B is theta, the angle between A and minus B will be pi minus theta. So I use the first formula, and instead of theta, I substituted pi minus theta. So if you give me alpha angle, I will substitute alpha here. That's it. Correct? So my answer will be positive only, right? The negative is coming why? Because we are choosing some other angle. We are not taking the angle between these two vectors. We are taking angle between the original vector A and B. Understood?
Yes, sir.
And now look at this. So okay, let me give you some questions to practice. So let's say someone says that there are two vectors A and B, and mod of A, or simply I can write like this. Let A and B are two vectors. Let A and B are two vectors such that the A vector is root 2 times B vector in length. So lengthwise, you can see which one is bigger. A is bigger length and B is smaller, because the root 2 times B gives you A length, and the mod of A plus B turns out to be root 3 times mod of A minus B. Now that's given to you. Okay. Now carefully find angle between A and B. So I want angle between A and B. That's it. These relationships are given. How to proceed? So first of all, you need to replace this modulus sign in terms of formula. Okay, and the best way is square both sides after writing the formula, and then you can substitute A equals to root 2B. So now you can simplify this. So can you try this question for a while? Then I'll attempt. Okay. So I'm giving you almost 5 minutes to solve. Then I will solve. Start everywhere. Don't worry if the answer is weird. You are not supposed to get 30, 40, 45, 60, 90 answer. You may get something very weird answer. Leave it the way it is coming. Don't worry. So you can start with the assumption that let's say theta is the angle between A and B, right? So the next step is logical step is writing the formula from here. So what I can write? Under root of A square plus B square plus 2AB. And since I have taken the angle between A and B as theta, I can write cos theta. Okay. Root 3 times under root of A square plus B square minus 2AB cos theta. For the obvious reason, now we square both sides. Squaring both sides because we want to remove the square root. And because we are looking for theta, so what we'll do is we'll bring the theta term one side. So this will come this side. But 3 will multiply here. So it becomes 3 to just 6 plus 2, 8. And 3a square plus b square minus a square plus b square becomes twice. Correct? So cos theta turns out to be how much? A square b square upon 4ab. Understood? This is the final answer. But now we have to use this relation to get a number. What is a? Root 2 times b. So you can just substitute a as a square as root 2b square. So a square becomes 2b square plus b square upon 4a, which is root 2b into b. So 3b square upon 4 root 2b square, which is 3 upon 4 root 2. Understood? So cos theta turns out to be this weird answer. Of course, it may look like nonsense to you guys, but that is totally acceptable in mathematics. So cos theta turns out to be 3 upon, and why this is the correct answer? What we need to really check is is it less than 1 or equals to 1? Any value which is less than equals to 1 is the correct value for the angle. These are new, these are numbers. So eventually this will become a number, and using calculator you can get this answer also by using the inverse function in calculator. So we can write as theta equals to cos, the way of writing is cos inverse, which is like a function. This is the way of writing. Cos inverse of this number gives the angle. So if you have calculator, I will show you how to get the answer. Okay, you have calculator. So you can use either mobile calculator or a laptop calculator also. It should be scientific. So in mobile, if you pull the button, you can see there is an inverse INV written somewhere. In the expanded form of your calculator, you can see INV written somewhere top. Can you see INV? Maybe in the landscape mode, you can see. If you're not able to see you can see the landscape mode. If you rotate your laptop, rotate your mobile phone like this, you can see. Can you see INV written somewhere or cos inverse, sin inverse written? Either this symbol or that symbol. INV. Can you see somewhere written here?
No, sir.
Okay, no problem.
Sir, I'll try on the laptop.
No. Every mobile phone will have. You have which just show me the mobile phone calculator page. Just show me. Anyone? Yeah. So in that you have some function. Okay, of course it's difficult to see. In that there must be some button with INV written. A button with INV written somewhere. INV. Nowhere. Okay. Anyway,
So IN is written.
IN is written. I know that's ln. That is ln. Maybe.
So that is log.
Log. Yeah.
Log.
That's log.
Yeah.
So I can see in my lab my calculator. Okay, I'll show you in the general calculator. Don't worry. I'll show you something. Okay. I'll just show you Google, just simple Google calculator. Look at this. Maybe this will help. So can you see the calculator on your screen? It's a very simple Google calculator. Okay. And you can see this is INV written here.
Yes, sir.
Can you see? If you click INV, it will give you sine inverse, cos inverse, tan inverse. Can you see? These inverse. So first of all, you need to insert the number. Oh, what was our answer? 4 by 3 by 4 or 2?
Yes, sir. 3 by 4.
Let me calculate. 3 divided by, I will put a bracket, 4. And how to write root 2? We have to use the square root symbol. And then 2. And we're done. I will press equal sign. So 3 by 4 2 gives me 0.53033 and so on. So what I'll do next, I need cos inverse. I'll go to inverse, we'll click. Now I have sine inverse, cos inverse, tan inverse. I'll put cos inverse. Of what value? 0.53. 0.53, that's sufficient. Put equal. You can see the answer is in radian. I'll convert into degree. So in degree, this should give direct answer. Anyway, let me, yeah, that's answer. It is roughly 58 degree. 57.99 degree is the answer. So if you use the cos of 58 degree, you will get the same answer. Okay. Cos of, so I'll just show you reverse process. Cos of 58 degree. I have taken 58, so the answer is 0.5299, which is 0.53, right? And this is exactly the 3 by 4 of 2. Understood? Cos of 58 degree is giving me 0.53 roughly. And okay, I'll do something like this, minus 4 by, I'll put in bracket, 3 by, no, back. 3 divided by 4 root 2. Okay. Minus. Okay. Or simply 3 divided by, is the wrong bracket. It's the same thing, 0.53. And cos of 58 degree, you can just say cos of 58 degree, I have taken degree here, is roughly same, 0.53. So that is how the inverse function, we call it inverse function. So once you press inverse, it will give you it will operate on the number and will give you angle. So what is inverse function? When you write cos theta, what is cos doing? Cos is a function which operate on theta to give you number. Okay. So cos theta means what? Cos is a function. Theta is a value on which you operate the function, which in turn gives you new value. What is the inverse process? You operate the inverse function on the number, you get the angle theta. You get the angle back. It's a reverse process. I'll show you by simple example. This may be difficult. Okay. I'll introduce you to some nice graphic calculator to practice graph to plot graph and get the intuition behind graph. Okay. So I'll show you the very famous calculator called Geogebra, and from this age one should be good with these uses, because the future is all about this. The bookish knowledge will not help. You need to know the tech, the present thing. I'll introduce you something really nice called fit. So in the US university, we have the fit website, which let you see the simulation for the maths and physics and chemistry all things. So you can go and perform online experiment. That's very interesting. Okay. So we have a very beautiful site called Fit Colorado. So it's a university in the US called the Colorado University. Okay. I'll just show you. Let me share the screen, new screen. Yeah, so this is the website. You can see fit. Let me zoom. I hope you can see now.
Yes, that's fine.
So you can see, if I click simulation, you can see physics, chemistry, maths. Let's go to maths. Let's see if we have some vector or not. So in maths, we have motion, maths application. Okay. Yeah, let's go to the, it's really nice. Center and variability, number plane, number line, distance, proportion. Vector addition, nice. See, which one will we do? We'll do the vector equation or vector addition. Okay, let's start with the
Equation.
vector equation. Huh? Fine. So we'll go to vector equation. It's really nice. And okay, we'll do the equation first. Oh, okay, I need to first search for the yeah, simulations. All right, it's loading. This is called fit. It's a new way of teaching to the present generation in US. It is compulsory in US that every student must learn this way, the simulation. It's one of the most expensive project in the world by some Nobel laureate. Okay. So we'll see the equations. Okay. Now simple equation. You can see here a plus b equals to c, and you can choose a value. And what is the value? Graphically, the length represents the magnitude, correct? So if I take this and if I change this to new value, see I have theta here. I should be able to so I will check this at theta. I think it's not working and they haven't given the modification option. This is the component. Anyway, you can see
I think you might have to check that values box.
when the value box is fine, but still that will only represent on the graph. What is the value? Uh, this. Okay, I can choose here maybe. maybe I can change A to, we can change from here. You can see, and C is the resultant. So once you change A and B, you can get the different answer, right? So let me make it the AY as 0. Let's say a vector is along the x-axis. You can see A vector is along x-axis. Can you see? AX is 7. I have taken AX equals to 7. And B, I'll make it 0. You can see A is like this, and I'll make a B at 45 degrees. That's fine. So you can see there A vector is at horizontal, B is at 45 degrees. So resultant is how much? You can see here is the answer 5.4. Okay. Let him take some nice values. Maybe 4, 3. And this is I'll take 5. Okay. And the angle I will change. So okay, A and B is given. So we have the angle. So B vector is at what angle? 53.1 degree. A is like this. So the C vector is how much? So if you look at the A plus B, you can see the C vector is 8.9 in value, and this is the resultant. And probably we cannot move it. Oh, we can move it. Yeah, you can see clearly. See, this forms the triangle. You can see. So C vector is forming a triangle. The whole idea is you can go here, you can explore this site and just play with it for some time. And going into future, it will help you having the visualization, how things can be visualized graphically. And the graphical visualization is important for the learning physics and math boards. Anyway, come back to the our screen. So cos inverse is a function. It's not like power minus 1. This is not a power. It's just a name for the function. Okay. So to understand this simple, what is sine 30 degree? 1 by 2. Understood. Which means 30 degree can be rewritten as sine inverse of 1 by 2. So if I ask you what is cos 45 degree, you can say 1 by root 2.
1 by root 2.
So which means 45 degree can be written as cos inverse applied on the number 1 by root. That's the meaning of inverse function. So inverse function is a function which when operated on the value gives back the angle. Okay. So if cos of angle, what do you mean by sine theta? So there is something called operator relation. Operator in mathematics, what we have is called operator. So if I ask you a simple question, what is the value of 2 plus 2? What is 2 plus 2? Everyone.
4.
How you know it's 4? Can you prove it? Can you prove
By
it?
adding 2 and 2.
Pardon? Anybody who can prove 2 plus 2 is 4? Difficult, no? See, something so simple is so difficult to prove. So we have something called number line. 1, 2, 3. Let me stretch it. And 4. And there are so many. And on the left of the number line, we have negative numbers 1. So when you write 2 plus 2, what does it mean? In mathematics, this plus sign is called operator. An operator is again a literature. it says that on a number line, you start at 2. Okay, so as per the instruction, we start from here. The plus operator says that walk along the positive direction. Okay, so I will walk by how much? 2 units. 1, 2. Where you land? At 4. So basically, you're not adding, you're again saying the same thing in literature. You're not adding anything. You're saying if you start at 2 and if you walk 2 steps ahead, the location where you will land is the 4. That's number 4. Oh my God, 2 plus 2 is so difficult. We never realize what is 2 plus 2. What is 2 minus 4?
-2.
Now let's try to use the definition. Is it giving the answer? You begin at 2. Minus means move backward. By what value? 4 units. 1, 2, 3, 4. Oh, wow, we are landing here. -2. Are we really separating? Are we really adding something? No. We simply walk as per the instruction on a road called number line. So this is a new path on which you walk, number line path. Okay, understood? So this is the one-dimensional number line. If you have two-dimensional, we have the two separate number lines. We call x-axis and y-axis. These are two separate number lines. It's just a mathematical way of saying something. Okay. So let's say if you walk 2 steps in the east direction and then 2 steps in the north direction. So let's call this as east, this as north. And let's say each step is 1 unit. And so on. So if you walk 2 steps east, how to write it? 2 steps I cap. That's the vector notation. And see how beautiful is this? And means plus. So the literature becomes plus. And walk 4 steps north. 4 j cap. So if you do so, where you will land from the beginning point. So you started here. After this movement, where you will find yourself? 1, 2, 3. So 1, 2. I'll reach here. I will take the left turn and I will walk 4 steps. 1, 2, 3, 4. I am somewhere here, right? This is my location. And how we represent it? So we say this is the position vector. That's simple. No? So what this position vector is representing? That this guy has walked 2 steps right and 4 steps up. You can say something like this. Okay? Or this guy has walked 2 steps in the x direction and 4 in the y direction from its own beginning location, the origin. So where you all started at O, and then you walk 2 steps. And why ing? I have to use C. Earlier I was not using here. Are we using ing? Because in one dimension it is not. There is no confusion. In one dimension you just walk along the single line, right or left. Okay. In 2 dimensions, there are 2 possibilities. You can walk parallel to x, parallel to y. So to distinguish these 2 separate walking, I need to create the coordinate axis. And that is how the birth of xy coordinate took place. By none other than the famous mathematician Rene Descartes, or the Cartesian came from the word here, Cartesian, C-R. So the coordinate system that he introduced to the world, we call it Cartesian system. Okay, a French mathematician. I think he must be French or something. The name is like this only. Some chocolate name, right? Rene Descartes. Okay, some maybe dark chocolate. Okay, quite possible. Nevertheless, the Cartesian system is a system in which we use mutually perpendicular direction as the coordinates or as the number lines actually. So these are the mutually perpendicular number lines in which we write number And the way we express is very simple. It's not difficult. You can understand these are the, I mean, when you say that a point in a plane, you actually represent with how someone can reach here. Like I want to exclusively express that location. So we cannot work like this. Why? Because if you work like this, we don't have the scale to measure, isn't it? So what is the way of, measuring this value? We either move along this line or this line, or one by one. You walk this line and then you walk parallel to this line. And while doing this, you make sure that you can read numbers. Understood? You make sure that you can read numbers corresponding to the line parallel to which you are walking. Understood? So that is the meaning of writing vectors. So there is nothing like vectors in the, it's nothing. It's just imagination. It's just my own mathematical picture of the world I want to create. So these are something called the basis on which we create the world, the mathematical world. So without introducing I and j, how can I express 2y plus 4j? I cannot. So that's why in the very beginning, I introduce you unit vector. I name these roads as I and j for your own convenience. I call that any guy who is walking along the x-axis is moving along the I cap direction. So I cap is the name given to the x-axis, j cap for the y-axis, and k cap for the z-axis. Do you realize this? What I'm saying? Do you realize? So a number line, if it is single line, then we are not talking about the direction, particularly I and j, because we have only one choice, and single choice we can fulfill with plus and minus sign. So that's why in one dimension, we generally do not use vector notation. We take care of the direction with plus and minus in one dimension. The moment you switch to two dimension, you have to be careful. You have to use I and j, or j and k, or k and I. In three dimension, you have to use I, j, and k. And three dimension is the dimension where the physical world stops. Now, after that, whatever dimension we have is the non-physical world. 4 dimension, 5 dimension, 6 dimension, 7 dimension, 8 dimension. It could be 1,000 dimension, billion dimension, and we have actually these dimensions. But mathematically, these are called abstractions. You cannot visualize it. Our visible, or you can say visualization power, is restricted to 3 dimension. So our brain is designed to only think 3 dimension. We cannot think or imagine or create the intuition for the 4th dimension. But you can understand the 4th dimension easily. Okay. And the 4th dimension is called the time dimension. For example, whatever I have said and you have listened, it is a past. It is a past, right? But it is stored somewhere it is stored somewhere. It is not lost. You can watch the video, you can see, okay, 1 minute before you were sitting like this, you were looking at this, you were writing something, you were listening to me. So this event is stored in time axis. Okay. Now, can we represent time axis on plain paper? No. But every event, so let's say this diagram is existing now also, and the same diagram will exist after 1 second. Now it is also existing. So this diagram is getting recorded in time. So now there is a 4th dimension, time dimension, or time axis. But don't get into all those things. That is a part of the theory of relativity. So in the theory of relativity, we study the 4 dimensions: x, y, z, and t. So the time becomes the dimension. Okay. But time is not the dimension, because time and dimension, why we say they are not dimension? Dimension means they must represent the number, right? So x represents, let's say x represents something like a distance. So y also represents distance, z also represents distance, but t represents time. So how to make this distance? By multiplying with the speed of light. So the moment we multiply t with speed of light, this becomes the dimension. And now these 4 dimensions we called four vectors. I told you that there is something called four vectors in the last lecture. So four vectors are like x, y, z, and time, but time multiplied with some velocity of light. Again, these are not required, but these, what you can get the idea that these are, it's just a design for our own convenience. So we design the number lines in a mutually perpendicular fashion so that a particular point in a space can be located by walking in a some certain manner. Okay. Now tell me, does it matter if I walk, if I from my origin, if I walk this way first, if I walk this way first, and if I go this way, does it matter? So if I write 4j and 2i, I'm here. 4j 2i, I'm at the same place, and 2i and 4j, I'm at the same place, right? So my location is same if I walk this way or this way, correct? That is called the commutative property. So 2i plus 4j is same as 4j plus 2i. Understood? This is called commutative, which means no matter what order you choose, your end result is same. The order does not matter. Now where the order will matter in our real life, I'll give you the example. Let's say you want to wear the shoes. What you do first? You wear socks and then shoes, or vice versa?
Sir, socks then shoes.
Okay. So if I reverse the process, what will happen? It's weird. I mean, people will say you are like mad. So will you wear the shoes first, then socks? So order matters in their life. Such events are called non-commutative event. Non-commutative. The event in which the order matters is non-commutative. The event in which order doesn't matter is commutative. That's all. Okay, so the whole idea is the order is not important when you're doing the vector addition. So in vector addition, the order does not matter. Where? In addition. So that is why in vector, writing A and B gives the same answer as writing B and A. And this is the one of the most core properties of vector addition. The vector addition is always commutative. So switching the order will not change the answer. So we call it commutative law. So commutative property. So if the order of operation does not affect the answer, we call commutative. If order matters, we say non-commutative. So vector addition must be vector addition is always commutative. If it is not a vector. So if something which cannot commutate, which cannot follow this property, let's say you think that someone is a vector, but it fails to follow the commutative property, what do we say? It is not a vector. So this is one of the finest rule of vector, and every vector is supposed to pass this rule. If you fail this rule, you will be thrown out of the community of vectors. So where we land, we'll become back to scalars. Understood? So you will again become scalar. Although you will say I have direction, but the world will say no, you are not passing this examination. This criteria is mandatory for every vector to pass, and because you failed to pass this criteria, I will not keep you in the category of vectors. You will become scalars. That's simple. So I'll come back to this concept again. So we went somewhere tangentially to other direction. This was not a discussion. What we are doing is some problem. Okay. So let's go back to doing some problem. So I'll teach you mathematics separately. There will be separate mathematics lecture in which I will show you the entire mathematics at once, from calculus to algebra to trigo and the world of entire mathematics, coordinate geometry and so on. Okay. So we will start the math after the vector is finished. We'll start the math. So let's do the next problem. Problem practice 2. So a very simple question. We have an equilateral triangle. So lengthwise, these all vectors are same length. So whether I call it A, if I call this as B, so let's say mod of A, mod of B, mod of C, all are equal. So it must be equilateral triangle, right? Without saying anything, you can understand that triangle must be equilateral because only in the equilateral triangle the sides are equal. That's logical. Okay. Let's say the value is 2 units. Okay. So first step is, what is the law here? What is the triangle law here? Triangle law. What is the triangle law here? What I can write? Your voice. You have to unmute yourself. You have to unmute yourself before you say. Unmute. Yeah.
So
Yeah.
C vector
P
is
is
equal
the
to
resultant of A plus B.
Correct. Very good. So C is the resultant of A and B, right? That's correct. Okay. So if all are 2 units, if I ask you a question, what is the value of C minus A modulus? See, C minus A I got from here only, no? By shifting A this side, I got C minus A. So C minus A is representing nothing but the B modulus, which is 2. It's given here. That's easy. Okay. If someone will ask you what is C minus B modulus,
A.
it's again 2 units. Correct. But if I ask you something different, what is A minus B? Now that's interesting. So can you tell me A minus B value, the modulus? You can draw the triangle, new triangle, as per the reversal of direction, and then try to calculate. So please do this. Find this answer. So what is the answer? So you need to first find the angle between A and B, right? What is the angle between A and B? What is the angle between A and B? Look at the triangle.
So is this an equilateral?
Of course,
Yes,
that
sir.
is
So what is
implicitly written. If the length wise both all are equal, it means it must be a equilateral
yes,
triangle.
sir.
Right?
Yes.
So now finding the angle is not difficult, no? So looking at the triangle, can you say that what is the angle between A and B vector?
120 degree.
Correct. That's right answer. If the angle between A and B is 120, so what is the angle between A and B? Sorry, A and minus B. What is the angle between A and minus B?
So 60.
Yeah, of course. So if you draw the minus B, how it will look like? Sorry. Let me draw this diagram once again. Just a moment. So now you know the angle. Can you use the formula to get the answer? So the minus B vector will be like this, the opposite of B. And now you can say
So
A,
is the answer 12 units?
root 12, no? Root 12. Root of 12, right?
Yeah, root of that.
That's the right answer. So if if you extend the A vector and if you look at the B vector, the angle is 60 degree only, right? So the resultant of these two vector will be like this. Tail of the first, then tip of the second. And we are trying to find this length. A. So this length we can write as A square B square 2AB into cos of angle between A and minus B, which is 60. Or you could have written the old formula A square plus B square plus 2AB minus A square plus B square minus 2AB into cos of angle between A and B, which is 120. So no matter which formula you use, you will get the same answer. Correct? So how much it turns out to be? So it turns
Sir,
out to be root
12.
2. And 12 root is basically 2 root 3, right? Correct? Can we solve in some other way? The answer is yes, we can solve multiple ways. I'll show you some common sense way, like without using formula. No need to use any formula. We can solve questions like this. The moment we have a triangle, I really do not care about the vector concept. I'll go back to the simply properties of triangle. Okay, so let me draw this once again. In triangle, the good thing is just think of a triangle only. Don't think much. So the minus B was like this, correct? And we were looking for this length, the blue length, right? Now look at this. This is 2, 2, 2. This is also 2. And this is how much angle? 120. Right? Now if this is 120, can you tell me what is this angle? because this is again isosceles triangle, right? You can see the bottom triangle. The bottom is isosceles triangle, isn't it? And in isosceles triangle, if the sides are equal, the angle must be same. So x plus 120 must be 180. Common sense.
X is 30 degree.
Correct. So now I know x is 30 degree. And what I'm looking for? I'm looking for this length, the bottom length, right? So I'll do a small construction, like common sense. I will drop a perpendicular. And the moment I have the right angle triangle, I can easily find the base. And the entire length will be how much? Twice of the base. So in the right angle triangle, how to relate this number and this number with this angle? Sine, cos, tan, which will relate these three numbers? Relate this with this using this angle. What we can do?
So cos.
Very good. So cos 30 is equals to base upon hypotenuse. So L turns out to be how much? 2 cos 30. So the entire length is how much? You can say the mod of A minus B is basically 2L lengthwise, correct? So the answer is 4. And what is cos 30?
√3/2.
See, actually, we're not supposed to solve anything. It's not vectors, it's just a mathematics. If you know trigonometry, you can get the answer. What you really need to know is trigo, not vectors. Vectors is just to draw the line. As per the rule of vector, we draw it. But once we have drawn the triangle, I really do not care was this vector or triangle. So once I have the triangle, I'll go back to the trigo and we'll solve. In most of the cases, I do this because that's pretty easy than using the formula. At the end of the day, we have to find the length. So do whatever it takes to find the length. That's it. Okay. So I'll just show you one very simple and famous example. So let's say a person is walking in a circle. So in circle, what remains constant? Radius. So let's call the radius is r. Okay. So a person goes from point P to point Q along the circle. You walk like this. Okay. And after walking from P to Q, they will ask you, find the displacement of the person, this guy. What is the displacement? And what is the displacement? The shortest path you join, right? Something like this. Okay, this is the high school definition, which we'll learn in a different way later on. But this is the basic idea of magnitude of displacement, not displacement. The shortest distance between the 2 points is called, what we call? The shortest distance between 2 points is called?
Displacement.
No, magnitude of displacement. Displacement is a vector. We can't say displacement. I'm asking the value. The shortest distance is the value. So the shortest distance between 2 points is called magnitude of displacement. Displacement is a vector. We'll define different. Anyway, so you go from A to P to Q, and as a result, the angle which you turn, they will give you this angle theta. So given the angle theta and the radius, can you find the yellow line length of the yellow line? Can I find this length? And we can find this line without using any vector concept. We can do it mentally, common sense. So which triangle is this? OPQ?
Isosceles.
Exactly. And the moment you have the isosceles triangle, what you need to do? Just draw it separate. Like this, the way I'm doing. This is always easy if you draw it separate. and think about what is given to you, r theta. And what I'm asking, can you find this length? Simple. So what we do, we always draw a perpendicular whenever we have isosceles triangle. Why? Because it will divide the triangle into two separate parts, equal parts. So drop a perpendicular. Once you drop a perpendicular, now we have the right angle triangle, because we are only able to solve question of trigonometry if the triangle is right angle, right? So sine, cos, tan, all are applicable for right angle. So when you have a triangle which is not right angle, the common sense says that can we convert into right angle of our choice, of our convenience? And that is the thinking process. Can you do this way? Now, once you drop a perpendicular, the angle will divide equally. What will be the value now? Theta by 2, correct? And if I call this entire length as x, let me call this entire length as x. So half will be x by 2. Okay. So now given the angle, can you find x? So which trigonometric relation will help you?
Sine.
Science.
Excellent. So sine theta we can write as x by 2 by r, and we are done. This is x by 2r, and we got the answer 2r sine theta. No need to think of vectors. Of course, we can do by vectors, but do we really need vector to solve here? No. The moment I have a triangle, I simply think of triangle properties. I think of right angle triangle. I think of what I can do with triangle to find the length. Okay. But if we would have to solve this question in terms of vector, so we have OP vector, we have OQ vector, and we have PQ vector. What we are trying to find? PQ vector, right? Now, what is the triangle law for these three vectors? What is the triangle law? Tell me, guys.
OQ is the resultant of OP and QP.
Excellent. Very good. So OQ is the resultant of OP and PQ, right? So how we write it? We write OP vector plus PQ vector is OQ vector. Any doubt in this? But what we are really interested in? We are interested in PQ, correct? We want the length of PQ, so we are interested in PQ. We can separate it. And what we'll write? OQ vector minus OP vector. And we are looking for length, so I can take modulus both sides of this equation or relation. And what is the difference formula? A minus B, we can think as A minus B. So what is the formula of A minus B? Okay, tell me, what do you know? Do you know the angle between OP, OQ or OP minus OQ? Do you know the angle between this and this or this and this? What angle is known to us? Can you check the diagram? We know the angle
Between OP and OQ.
correct. But what we need here? OQ and minus OP. Understood? Which will be pi minus theta. So what we can write here? OQ modulus square R square R square. And can I write directly minus 2 R square cos theta? Because of the obvious reason. And I'm done. What I'm left with? Under root of 2R square 1 minus cos theta. Now you can see this answer is not matching the answer which we're looking for. So how to match? So for that we need some rules of trigonometry. And what are those rules? Let me show you. The rules are simple. 1 minus cos theta we can actually write as 2. So as of now you remember, I'll tell you how. Okay. Basically the formula is 1 minus cos 2 theta is 2 sine square theta. From where it came? It comes from the trigonometric identity. And what is that? This is cos 2 theta formula. And from there, where this comes? Cos A plus B. What is cos A plus B? Cos A cos B minus sin A sin B. What if I put A and B as theta and theta? Cos theta cos theta, which will become, and this is exactly cos 2 theta. Understood? And this we can rewrite as okay. I'm not teaching trigonometry. I'm just writing quickly so that you can understand. So we can write 2 sine square theta equals to 1 minus cos 2 theta. So sine square theta is basically, oh, you can write. So if I put theta here, so if I put theta by 2, understood? And similarly, I can convert, like if I put theta by 4, and so on. We can keep on writing like this: theta by 8, theta by 16, 32, and so on. The idea is you are supposed to remember this relation. That's it. Okay. So anyway, I'm not teaching right now, so that's why I just gave the quick review. So 1 minus cos theta we can write as 2 sine square theta by 2. And now you can see 2 and 2 comes out. So everything is squared, so we can bring everything once outside. And now answer is matching. You can see same answer. So do you realize this, guys? Is this clear?
Yes, I got it.
Yeah, you can just spend, yeah, you can spend some time and think about it, what we are doing. So every question of vector we can solve. See, we need a vector to draw the triangle law. Once the triangle is drawn, you're free to do the way you want. Understood? You're free, totally free. In fact, every question you can solve from basic or scratch. So let's say if I draw a triangle like this, first vector, second vector, let's say 60 degree for the sake of writing, and they're asking me to find the a minus b vector. So this is minus b, and someone is asking me what is this length, which length? So basically, if this is a, this is b, this is what? A minus b. Is this clear? As per triangle law. Do you realize this? Yes. And now this is 60 degrees, so this is also 60 degrees. And see, asking this length is simple. I mean, you just tell me this is a triangle. I will just draw a triangle. I will not think much. So lengthwise, this length will be called A and this length will be called B, because lengthwise minus B plus B all are same. Correct? And they're asking this length X. That's it. I need to find X, isn't it? Of course, you can use vector formula, but what I'm trying to say that no need of it. You can just use the cosine rule from mathematics. And what is cosine rule? In any triangle, If this is A, this is B, this is C, and if I say this angle is theta, then cos of theta is written as A square plus B square, the square of the adjacent sides minus opposite side square upon 2 adjacent sides product. That's the rule. We can prove it later on. That's easy.
So this is for any triangle.
Yeah, any triangle. Doesn't matter. Now it doesn't matter which triangle, what shape is this. It really doesn't matter. You can use it anywhere. And once you use this formula, see, I'm done. Why I'm done? So I can apply this concept here. Cos 60 must be equal to how much? A square plus B square minus X square. Why? That 60 degrees between A and B. So we square and add. We subtract the opposite side, X square, and we write 2AB. We are done. So what you can solve this? A square plus B square minus X square equals to 2AB cos 60. What is cos 60, by the way? Half.
Half.
And then therefore X square is how much? So X I got how much? I'm done. I really do not care about the vectors. But let's say if I want to solve using vectors, so how I will solve? A square, B square. Theta is the angle between A and B, then minus, okay, like this, okay. So what is the angle between A and B? You can see angle between A and B is 60 degree. Can you see that? And so the answer is same.
So can we do it in the format of A square plus B square plus 2AB cos 120?
Exactly, that's the same thing. Why not? I will change the cos alpha. And the alpha will be how much? That's it. And cos 120 is minus half. That's the answer, minus half. So why we don't let you write like this? Because you need to know the obtuse angle value. And again, so you can use method 1 using acute angle value. I mean, not acute, obtuse, just formula. And of course, you can play with vectors. The triangle law having only one use: draw the triangle properly. That's it. It is clear. So I'll show you some advanced way of thinking, or some way of thinking in which we can do it mechanically, like how to solve question mechanically. I mean, sometimes you're not able to visualize for some reason, or many students is having this problem of they're mathematically very good. So some students who are very much into mathematics, they don't see the visualization part, they can see abstraction directly. I mean, they have some natural ability to solve the question only by looking at the formula. They don't care of the graph, the shape. Okay. So if I give you any question, let's say if I tell you that vector A is resultant of B and C, and let's say angle between A and B is known to you. So this is the relation of triangle law, and this is the value, the angle value know. So you know angle between only one pair of vector. Now how many pairs we have? Basically 3 pairs: AB, BC, CA. So in a triangle we have 3 pairs. Out of 3 pairs, you will be knowing angle between any one pair. So which pair I know here?
A and B.
Okay, we know A and B, but the triangle law says A equals to B plus C. So the rule says you must bring the vectors on one side of equal sign whose angle is known to you. So what will be my next move?
A vector minus B vector.
Exactly, because I know the angle between these two vectors, I'll bring on the one side. This is the step one. Anyone solving the question mechanically, you have to think this way, because I know the angle between A and B, I'll bring them on the same side. If they are on the same side, you're lucky. If they are not, bring it. This step is clear, everyone? Step two, take modulus both sides. Take modulus both sides. If you take modulus both sides, what will happen? A minus B equals to like this. And because we know the angle between A and B, can we write the formula now? Can we write the formula? So under root of, or you can square right away. You can also square both, I mean, right away. But anyway, the formula will be how much? A square plus B square. Now, plus or minus? Let's say the angle is theta. So what we can write next? A square plus B square minus 2ab cos theta. And this must be equals to, or simply C. If you can write, you can just write C. And now what we will do is we will square both sides. No, don't do. So let's say something is given, you can solve the question. And how to solve the question? They may give you A, B, and C length, and they may find you, they may ask you the theta, they may give you theta, they may ask you C value. So variety of question can be asked. Okay. As a student, when we start solving vectors, we need to have an eye for looking at the angle clearly, distinctly. If you can see the angle, you can master vector. Angle is important. I'll show you some other question. So see how to solve this question mechanically and how to solve the question logically, I mean graphically or in one line. So we have three vectors are three vectors whose magnitude so we have three vectors whose magnitudes are 3, 4, and 5 respectively, which is a very famous Pythagorean triplet. Okay, this is called the Pythagorean triplet. I hope you have heard. So we have many one like 5, 12, 13. Okay, so we have many one like this. These are called Pythagorean triplet, which is very famous. So now these are given. So what do you know? You know mod of A is 3, mod of B is how much? 4, and mod of C is 5. Okay. And what else is given? The law is given. What is the law? A plus C equals to B. Okay. So what is the question? Find angle between A and B. So is A and B on the same side? No. So what we'll do, we bring on the same side using the given law. See, we cannot create the law. Law will be given to you. You have to bring the desirable vectors on the same side. So how to start solving question? The first logical step is bring the vectors on the same side whose angle is desired. So you're looking for the angle between A and B, right? So can I write A minus B equals to minus, it doesn't matter because minus or plus lengthwise they are same. So the next logical step is, can you take the modulus? Why modulus is required? Because the formula is only for modulus, not for the vectors. Vectors don't have formula. They are just literature, a piece of literature which you put on the paper. When you take the modulus, then formula will come into picture, correct? So now we want angle between A and B. So this formula we can write as under root of A square B square. Can I write minus 2AB cos theta? Because angle between A and B they are asking, not A and minus B. So I will take theta as angle between A and B, so I can write minus 2AB cos theta. And this is C. Now the next logical step is square both sides and put A, B, C value. Because everything is given to you. A, B, C is given to you. Square both sides and put A, B, C. Can you solve for theta? The cos theta basically. So please do it and let me know the answer.
So I'm getting the answer as 25 by 24.
25
So theta is 90.
Maybe. See, 25 by 24 is itself is more than 1, which is something wrong. So maybe squaring is part is some, just recheck the length part. You have to square both sides, no? So C becomes 25 this side, right? So let me write one. A square plus B square minus 2AB cos theta is equals to C square. What is A, by the way? 3, 4, and what is C square? So what we have, this will cancel out. 3 square plus 4 square is 5 square with the Pythagoras. If you add it, it's 25 only. So what we are getting is cos theta equals to 0. Theta is how much? You got your mistake where you did wrong. Okay. Now this is the mechanical way, like someone who is not, I mean, who just want to solve mathematically. But as a physics student, I do not want you to be like this. I want you to be a person who can visualize. So in physics, we appreciate the graphical methods because that is always easier. Now, because of the values, I can directly draw a right angle triangle, no matter what. I can directly draw. Just draw the right angle triangle. Now tell me, which one must be C? Now A and B can be this or this or this or this. You can choose A and B any random. Okay. Because if C is the biggest side, C must be the hypotenuse. So A and B are bound to be these two only. So I can directly tell the angle is 90. I'm done. No need to solve. But what is the triangle law given? A plus C is B. A and C must be having same direction. So A and C equals to B. This is possible. See, this arrow will satisfy the triangle law. Or you can reverse everything. This. So you can choose any of the one of the arrow, because I just want to satisfy the law. So my law is satisfied. What is my law? My law was A plus C equals to B, correct? So A plus C equals to B. I'm done. You can see A plus C is B. The order is same, and this is the reverse order. The tail of the first to the tip of the second. Okay. So we are getting this answer. So A plus C becomes B, and this is the law. Okay, you can clearly see what is the angle between A and B. This is tail to tail already, and the answer is 90. But what are the other benefits? Other benefits are, I can find the angle between any other vector also. What is the angle between B and C? Alpha. What is the angle between A and C? What is the angle between, sorry, beta? Just a minute. What is the angle between A and C? Can you guess?
So 90 minus alpha.
No,
180 minus beta.
exactly.
Oh, so vector ANC.
Of course, I mean, see, vector A and C. We are asking the angle between vectors. So angle between vectors A and C will be how much? Pi minus beta, isn't it? Okay. So now drawing the graph gives you multiple information without solving, no? But imagine if you're doing everything mathematically, you have to solve everything separately. So do you realize the power of graphical method? In physics, we always encourage everyone to, or at least think about graphical method as much as possible. And you will realize that vector method or graphical method solves the most of the challenging problem in one line. So mathematical methods are sometimes good, sometimes really bad. So we have a trade-off between 1 and 2. Okay. So this demands a proper visualization, and we're done. So I can find cos alpha also. What is cos alpha, by the way? Or tan alpha, or whatever you want. Cos alpha is how much? B by C. Correct? What is B by the way? B is 4. So 4 by 5. And you know what is 4 by 5 value? What is cos alpha 4 by 5? 37 degree. Roughly, close to 37. Because this is very famous triangle, 3, 4, 5 triangle. 3, 4, 5 triangle is very famous. I'll just let you know the values of 3, 4, 5. 3. It's easy to remember. So tell me, guys, which side is the shortest? Bottom. So let's call this as 3, 4, 5. So in the 3, 4, 5 triangle, this is a bigger angle. This is the small angle.
53 degree.
And 37. These are rough values, not exact values. Okay. So now you can see what is sine 37.
Three by 5.
And what is cos 53?
3 by 5.
Exactly, because they are complementary angle, right? So sine of complementary is cos value. So this is always cos of 53. What is sine of 53?
4 by 5.
Which must be cos of
37.
37. What is tan of 37?
3 by 4.
And what is complementary of tan? Cot.
53.
Basically, the cot is nothing but co plus tangent, and co means complementary of tangent. Tan is tangent. The name itself is the answer. What is cos? Cosine, complementary of sine. What is cosec? Complementary of sec. Okay, or sec means basically secant, a secant line. So secant, cosecant, tangent, cotangent, sine, cosine. So we have like this: sine, cosine, tangent, cotangent, secant, cosecant. Simple. Now you know which are complementary of each other. So sine, cosine are complementary. Tan and cot, and secant and cosecant. The name itself is like this. And in short, we write sine, cos, tan, like this. Okay. So these are the actual name. And then we have the inverse, which is called arc sine. We write as sine inverse. Arc cos. We write as cos inverse. These are the old traditional literature. So if you study any old book, the book which was written maybe 100 years back, they use the arc word for inverse. Now we don't write arc, we just write cos inverse, sine inverse. Okay. So this why I'm giving you these symbols, because when you're solving numericals, and if a coaching institute has used this question from the old book will write arc, ARC, which means the inverse value. Okay, so not a big deal. Also in most of the old authors, they use this notation. So anyway, I will explain this in mathematics, known to well. So 3, 4, 5 is very famous values, and these numbers are easy to remember, not difficult. And if in case you forget, what you can do, draw the triangle according to the size. You will get all answer. 3 is the smallest, 4 is bigger, 5 is the biggest. Okay. So just in case you forgot, you remember this triangle. This is called 3, 4, 5 triangle. Okay. So okay, okay, we have done most of the questions which are important. Now I'll go back to the same. This one very important question, that's very important, which we haven't discussed, which I will discuss now. Okay. Sometimes they don't mention the angle between vectors. Sometimes they don't mention angle between vectors. What they do is they give you condition. So this is very special one. Let me tell you the question. Find the resultant of two vectors if the resultant itself is perpendicular to one of the vector. See, this is like again a literature. It's a piece of literature which we need to decode. What is a piece of literature? Find the resultant of two vectors if the resultant itself, okay, let me put a comma, if the resultant itself is perpendicular to one of the vector. When this is possible, I mean, what kind of triangle will be this? So let A and B are two vectors, and assume resultant is perpendicular to A vector. See, I have no idea which one, so I can choose anyone. Okay, but the moment I choose A, how the two vectors will look like? If I call this as A, very carefully, think very carefully what I'm saying. If I choose this as A, my resultant will be like this. So this is my resultant vector R vector. Correct? As per the question, this is the graph I can draw. With my assumption of A, what I assumed here, I assume that the resultant is perpendicular to A. Okay. So can I draw this diagram as of now? For this, for these many information, we can draw up to this much. Now tell me how the B vector should be. The B vector have no choice but to the end of the beginning of this end of B, end of A and this point. Because if R is the resultant, A and B must be like this. Correct? Do you realize this? And by looking at this diagram, can you tell me something interesting? The resultant is perpendicular to which vector? The small or the bigger?
So the smaller.
Always. If the resultant is perpendicular, the only option is it must be perpendicular to the smaller vector. It cannot be perpendicular to the bigger vector. And now, once I have drawn this triangle, graphically I am done. What is the length of resultant? I have solved this question in one line using graphical technique. Now imagine someone trying to solve this using the abstraction, the mathematical way. So how to attempt question in a mathematical way? It will have some pros and cons also, but we should know this method as well. So let's go back to solving the question mathematically. Okay, by the way, what is the angle between A and B? This angle? Or this inside or outside? Which one?
It's outside.
So let's theta is the angle between A and B. What is this angle, the inside one? Okay, what is the relationship between A, B and pi minus theta? Like inside the triangle, because to write the triangle law, I mean trigonometry, to use the trigonometry, I must know the angle within the triangle, right? So given this angle pi minus theta, and this length is B, this length is A, R is not given. Keep in mind, R is not given. R we have to find. What is the relationship between A, B and theta? This angle?
Cos 180
Oh.
minus theta equals to A upon B.
Excellent. So can that pi minus theta equals to cos inverse A by B? So can we write theta equals to pi minus cos inverse A by B? Just rearrange, right? Can we write like this?
Yes, sir.
There is the other way of writing. If cos pi minus theta is A by B, from the again trigonometry, cos 180 minus theta is minus cos theta. And therefore this we can also write like this. And therefore the cos theta also becomes minus A by B. So you can see there are two ways of writing. So theta is cos inverse minus A by B. And if you compare these two methods, you will get the third method. I mean, third relation. And what is that? Cos inverse of minus A by B is pi minus cos inverse of plus A by B. Because to remove the minus, and I can rewrite like this. Now, this is very famous way of writing. Okay. But in all of this, what I was really looking for is this answer. The mathematical condition is that cos theta is minus A by B. So I'll go back to the formula of resultant. What is the formula of resultant? Under root of A square plus B square plus 2AB cos theta, which is how much? Minus A by B. And you can clearly see the B cancels here. This is A square plus B square minus 2A square, which is exactly B square minus, oh, slightly longer method, but the longest one. Okay, this is not perfectly maths. I have used the graph actually to solve this, but how to solve purely mathematically without understanding the graph? Like if you have no visualization, can we solve it abstractly using pure mathematics? Now that's a different way of thinking. Imagine you cannot see the picture, then how you're going to attempt the question? So the abstraction is interesting. So for that, I need to go back to the derivation, very first, the last lecture derivation, and I will draw the diagram which I had drawn earlier, and we'll try to understand something. So if this is the resultant vector and if this is the A vector, can I say alpha is the sorry, can I say alpha is the angle between A and B? Alpha is the angle between resultant and A vector. Okay, and if I can say so, we can drop a perpendicular like this. Okay, and once you drop a perpendicular, you can find the alpha. Why? Because we know. Okay, let me draw the triangle only, not the vector, just triangle, pure triangle. The triangle law is done. We do not need further. And let's draw the simple triangle. Always remember one thing. In trigonometry, the only triangle which you can deal with is the right angle triangle. So it's a common sense that we must convert something into right angle if it is not right angle. That's our logic, always. And therefore, given this value A, this as B, this as theta, look at the right side, the small right angle triangle. What is this length? B cos theta. What is this length? B sin theta. Okay. And what is this the alpha angle? So what we can what we can write? What is tan alpha?
B sin theta upon A plus B cos theta.
Excellent. So now this gives you the answer in terms of A and B without using R, but you can of course write cos alpha also. What is cos alpha? You can also write sin alpha. What is sin alpha? Now using this formula, can we solve the same question? So what if alpha is 90? If alpha is 90 degree, the tan alpha becomes undefined. Tan 90 is undefined, it's infinity, undefined basically. Cos alpha becomes
0.
0. And the sin alpha becomes 1, which is of no use. I don't like it. Anyway, I have 3 options to choose from. I will choose the center one. Because cos alpha is 0, which simply means the numerator is 0. So cos alpha is actually A plus B cos theta upon unknown value R. But if this is 0, this implies the numerator must be 0. Correct? And if the numerator is 0, can we say cos theta must be minus A by B? See, now I have done abstractly. This is the complete mathematical way of doing. Like I'm not thinking graph. I'm drawing a random graph to derive the formula, and from there I am coming to the conclusion that okay, given alpha is 90, this is the only possible relation. Once again, given alpha is 90, this is the only possible relation between angle and vectors. And here A is the small value. It should be, because the ratio of A and B cannot exceed 1, right? Ratio of A and B cannot exceed 1, isn't it? All sine and cosine functions lies between -1 to +1. Understood? Any sine or cos function will be from -1 to +1. So A by B must be between -1 to +1. So A is always less than B numerically. This number should be fraction, right? So A is less than B, which means A is smaller in magnitude than B for sure. So mathematically it is defining that A is less than B in magnitude. Okay. Now once you derive this relation, we have the resultant formula. And here theta was not given, rather a condition was given, alpha is 90. Theta was not given, a condition was given, alpha is 90, which led to the relation cos theta is this value. And therefore we can now substitute. Which gives the relation that we wrote earlier. How much? So although slightly difficult, but we can solve. Okay. But what are the benefits? Let's say they may give you the alpha value and they may ask you theta value. That's also possible. Given the alpha, they can ask you theta also. So you can choose any formula. The best formula is this. Why? Because here we are not using R, we are using A and B. These formulas are having different difficulty that they use R. So I need to calculate R first, which is again complex. Okay. So we are going to use this more often in finding the angle between resultant and A vector. Okay. So this is the angle between resultant and A vector. So A is in the denominator. Okay. Something like this. So this triangle diagram, this diagram is the universal diagram to solve any question vector. So the moment you come across a new problem, draw this triangle and try to correlate the situation and you will get the correct answer. So this was the most difficult part, and so I thought of writing it separately as a numerical. Okay. But graphically it was very easy, no? Graphically it's very easy.
Yes, sir.
Okay, so just we'll write the R. So how we write R? A square plus B square plus 2AB cos theta. Okay, what if theta is 180 degree? If theta is 180 degree or pi, which means the vectors are exactly opposite. Vectors are exactly opposite. So what will be the answer? So we can write R equals to under root of A square plus B square 2AB cos pi. What is cos pi? No one knows. Cos pi is -1. Just remember as of now, we'll study in the table. So cos pi is -1. And if I substitute, what will get?
A minus B.
No. A square plus B square minus 2A. Now resultant is the length, and length cannot be negative, right? Length cannot be negative, isn't it? So how you know it is A minus B? Can it be B minus A? Why not? It could be. I don't know which one is bigger, A or B. Do I know? So this can be written as either A minus B whole square or B minus A whole square. Right? So we have no idea. So in such case, the mathematical way of writing is mod of A minus B, because I don't know A is bigger or B is bigger, and that is the difficult part. Like most of the students, they do the same thing. They write A minus B. No, A minus B is not the answer. A minus B modulus, because I don't know which one is bigger. Okay. For 0 degree, it's very simple. So if theta is 0 degree, then both are having same direction. So R will be, and this will transform into, and now we have no doubt. So here the ambiguity is not there. We can write like this, which means if the vectors are having the same direction, you can simply add. No need to worry. Just add them, and you will be happy. You will get the answer.
Got it, sir.
Yeah. Okay, so I think, okay, this is 2038. Okay, that's too much for today. Okay, and I'm going to share some sheets. Okay, I have shared one sheet with you guys, vector, the mathematics. Okay, once again I'll share. Just a minute. Just a minute. Yeah, just I'll reshare it. And I will share something more. Just a moment. For practice, just a minute. Okay. So almost there are 100 questions in this, but not all of from the triangle law. But you can solve the triangle law part. Wherever you see the triangle law, you can solve. So let me tell you what you can solve. I mean, mostly you can solve. You can solve most of them. So try as much as possible. If it is cross and dot product, you can just leave it. Let me see the answer also. The answer should be there. Just a minute. You can solve from here. These are questions which you can finish in 1 or 2 hours. It's not very difficult. It's just for practice. Then I'll share the challenging problem very soon. In fact, let me share that also. No, these are the sheets without answer, so that we can discuss. Just yeah. Okay, so too much. Don't solve this right now. This is the end. When you finish the entire vector, then you are supposed to solve these questions. Some questions are difficult, some are easy, some are very difficult. Okay, so you start solving. At least you have to start right now. In one day, you can finish. In 1 hour, you can solve 10 to 12 questions easily. They are just basic formula-based questions. The dot and the cross I haven't taught, so just wait for. You have to wait for some time. So this is a big chapter, and we're going to see the entire physics through the lens of vector. Okay, that is the whole purpose of teaching vector, not just vector. After learning vector, you can solve the vector of mathematics also. So if you have a vector chapter in maths, which is the end of the course, you can finish right now almost. You can finish almost 80 to 90% of mathematics also. So that much I will finish or cover here in the name of vector. Okay, so all right, guys, good night and take care. We'll meet again on Friday. Okay, bye, guys.
Bye, sir. Thank you, sir.
Bye.